Hello Year 11. So today we are pushing through with our exponentials and looking at or introducing Euler's number. Okay, so this number is something that we want to become familiar with now. Okay, we use it. It's basically the starting point for exponentials. It's a special number in the fact that it's like pi, okay? It's an irrational number that goes on and on and on. There's no specific pattern to the numbers, but it's a super important number. And we're going to find why, especially when we look at logs and then use it in calculus. So it was invented, we represent it with the letter E. And if you have a look on your calculator now, you'll find on your calculator there is a button for it, just like there is for pi, okay? So become familiar with where that button is. I think that you'll find it in yellow on most of your calculators, in yellow writing above the LN button. So on your calculator there's an LN button, and most of you will have the little E or E to the box above it, okay? So, simple questions in your textbook will ask you to just evaluate calculator answers. So here's our number. So if I needed 2e, you can just put 2 timesing by e to the power of 1 in your calculator, and you'll get this number here times by 2. So I'm not going to spend time just doing the basic arithmetic, but there are questions like that in your textbook. What I want to look at is the more important part of what's so special about this number. Here's the graph for it. Now notice that it's very close to the number 2. So we could assume that the graph is very similar to graphs we looked at last lesson, like y equals 2 to the x, okay? It's just a decimal this time. But there is something special about it. Now, earlier in the year, some of you, for your investigation, investigated the exponential graph, and a couple picked up this important point, which is, on the exponential graph, we know it passes through 1, just as we discovered last lesson, anything in this form, because anything in the power of 0 is 1. But what's super special about exponentials is, if I pick, let's say this point here, where x is equal to, let's say 2, what happens is, the gradient of that function at that exact point, so the gradient of the tangent, is the exact same as the y value at that point. So that's what's special about it, okay? No matter where you pick, the gradient of the tangent at that point is the exact same number as the y value at that point, which is what part of what makes this number so special. Now we know gradient relates to our derivative function. So what you'll find, and we look at this more next lesson, that if you take e to the x and you differentiate it, you get e to the x, okay? All right, so let's have a look at now some transformations of our graph y equals e to the x, very similar to our transformations from last lesson. Okay, I won't go into the positives and negatives again because it was very similar. Well, it's the exact same thing as last lesson, okay? So when you've got y equals negative e to the x, it's going to flip that graph upside down. So then when you have y equals e to the negative x, it takes that original and makes it a negative gradient. So then, of course, when you have y equals negative e to the negative x, it flips that negative gradient version upside down. So I'm not going to go back over that as per se, but let's have a look at now. I've represented A, B, C, and D with different values that could affect these exponentials. Okay, so let's start by looking at A. If I have the graph, let's say y equals 2e to the x, what happens now is this 2 is going to be where that graph stretches up and passes through on our y-axis. Now, I don't like using the word passes through because we know that when it gets shifted up and down, that number can be affected. But it's kind of like trig with our amplitudes, okay? It can affect where it passes through. So I'm going to say it stretches and affects y-intercept. So the graph y equals 2e to the x, we are going to get a graph that then still has an asymptote at 0, but passes through at 2. So see how it stretches it up? It doesn't shift it up because it's still got the exact same asymptote on the x-axis there. Okay, so now let's go over to D. It's the nice one. Same thing for every single graph you could ever draw. It shifts the whole thing up and down. But what you need to be careful, this will change our asymptote. Okay, so when we have our asymptote originally on the axis, it's going to shift it up or down. So for instance, y equals e to the x minus 2. Well, let's think about that. It's going to be now at an asymptote at -2, but it's still our original graph. So it's going to pass through at -1 this time and look like this. And later we'll be able to solve these and find the x-intercept, but at the moment we can't. But that number is now our asymptote. Okay, it's a good way to think of it. Okay, so then we have B. So this here, it just changes the steepness of the graph. So if I have y equals e to the 2x, it's still going to pass through at 1 because when we still have power of 0, we still get 1. But what's going to happen is it's going to flick up a little bit faster. I probably could have even drawn that a bit better. Okay, it flicks up quicker. Those values exponentiate more, if that's a word, exponentiate. Anyway, the last one is C. This is always the one that I didn't like because I found it just a little bit more confusing than the others. But C, the best way to think about this is if I jump straight into an example. What if I gave you y equals e to the x minus 1? Okay, let's think about that. Let's think about now, what value of x will give me a power of 0? Because then I know anything the power of 0 is 1. So, well, we can see here, if I sub in the value of x being 1, I'm going to get e to the power of 0, which gives me 1. So that tells me that at the x value of 1, I have e to the power of 0, which gives me an answer of 1. It's still in the form of e to the power of something, which means that it still has our asymptote along the x-axis. But what happens now is it passes through that point there at 1, 1. So whenever I have a c value affecting my exponential, I find it easy to imagine what's going to give it a power of 0, plot that point on there, and I would show the mark of that point, and then you can draw the overall nature of your graph. So now saying all of that, let's have a go at a few together. Okay, so let's have a look at some of these that I've just put together. So copy these out. If you want to pause the video now and give them a go on your own using those transformations, but otherwise I'm going to jump straight into it. The first thing I'm going to do on A is say, well, I know that there's an asymptote now at +1. So I'm going to put my dotted line and I'll put my 1. Now, what I do know is this 2e to the x, well, that original graph had an asymptote of 0 but passed through 2, okay? So it has that spacing of 2, which means my asymptote now is at 1, so it's not going to pass through 2 because that's only one space up from the asymptote, but it's going to pass through at 2. And that's not a very good drawing, but I've got the most important features on there. Okay, you want to always label your asymptote, label an intercept, or at least a point that it would pass through. Okay, this next one. Straight away, I say, well, okay, I've got a asymptote at 0 still. Think about that point that's going to give me a power of 0. Well, I know that at x equals -3, I'm going to have y equaling to 1, because at -3 I have e to the power of 0, and anything power of 0 is 1. So at -3 I get a y value of 1. So I know that it passes through this point. I know that it has the asymptote as normal, and technically I could find the y-intercept, because I know that a y-intercept occurs at x equals 0. So if I sub in x equals 0, I get a y-int at e to the power of 3. Okay, so we could label that on there. But so now if I join everything up, I can label that as e to the power of 3. And I'll show the marker. I know it passes through -3, 1. There we have it. Okay, last one, straight away. Asymptote is at +1. So let's sketch that in there. Now, this is a negative graph. So it's a negative at the front. So straight away in my head, I'm thinking, okay, that's got the nature looking something like this. Normally passing through at -1. But because this had our stretching component, it would have passed at -4. But then that's been shifted up 1 because of the +1. So now we know it's going to pass through not -4, but at -3. And let's see how my drawing skills go. There we go, not too bad. There's my graph. Now again, we can find the x-intercept later in the topic when we look at logs. So for now, we just leave it at that. Okay, let me give you a couple more, and then I'll just put up my answers for you to check. Okay, copy these down, pause the video, give them a go, because in about 5 seconds, the answers will appear. Okay, here they are. So let me just talk through them. I think they actually got easier as they went through rather than harder, but let me explain the process. This first one was tricky. The first thing I did is I said, okay, it's got a -x, so I know that the gradient's going downwards, so that's the overall nature I know the exponential looks like. I said, okay, well, I know that e will be the power of 0 at x equals 4. When I put in x equals 4, I get e to the power of 0, yep, but then it's +2 this time. So the y value is y equals 3, okay, 1 + 2. So then I know that it passes through the point 4, 3. So I've put that on here, 4, 3. And I know it has an asymptote at 2, and I know that that was my overall nature of it. So there's my graph there. Okay. I do know that the y-intercept, if I make x 0, I get e to the power of 4 + 2, which is a huge number. Not huge, but huge in terms of our graph, which is 50-something. So I'm not going to even put that on there because it's going to throw my scale out the window. All right, the next one. Okay, so it's got an asymptote at 50. It was going to pass through at 200, but then it gets shifted up 50, so then it's going to pass through 250. And the 0.5 is just quite shallow. Okay, so there's my asymptote, my y-intercept, and the overall nature. Then we have F. Okay, overall nature. Well, it's a negative and a negative gradient, so I knew that the overall nature looks something like this. It's always good to have that in your mind. Then if I ignored the -2, I'd think to myself, well, this graph would pass through at -3, and it'd be pretty steep, because that 2 there is there. But then that gets shifted up 2. So my asymptote is at 2, which means it won't pass through at -3 anymore. It'll pass through at -1. And the last one, we have an asymptote at -1. It would have passed through at 5, but then it got shifted down 1, so it's going to pass through at 4. Okay, so exercise for today. So I just want you to have a look at questions 1 to 4 only. We're going to do the rest of them in a separate lesson. Let me know how you go.